Dear folks, today we are going to learn how to simplify the industrial problem into a linear prime model so that we find the optimal solution. On the UAE National Day, children wear new clothes with the national flag embroidered on them. Our tailor has 3 weeks before the National Day and plans to work for up to 40 hours per week for the next 3 weeks. So you see constraints are given that a tailor has only 3 weeks, that is the maximum time tailor has, and he has a plans that 40 hours per week he will be working. So in total you see he will be having the in hours he will be having the 120 hours, since he has 3 weeks and 40 hours per week he will be working, so he will be having a 120 hours per week in total. 120 hours in total um, he has before the national day, so he has to manage within the stipulated time. He earns a revenue, so the revenue equation is given. You see he earned a revenue of 100 AED, um, Emirati dirham, 100 for stitching a pant, and Emirati dirham 80 for stitching a shirt. So these are the prices he has. So what we have to do, we will have to find out the maximization of profit function. So this must be our objective, to find the optimal solution of the profit maximization. So we will be finding the number of pants and the number of shirts count, so that tailor can get the maximum profit. He has a stock of 90 meters of cloth. Now constraint, the total cloth he has 90 meters, 80 units of packaging material. So packaging material is also required, because you cannot give the cloth as it is, you have to pack it as well. So packaging material also counts. If you have the less packaging material, the the pants are ready, the shirts are ready, but it cannot be delivered to the customer. So it is also a constraint. 80 units of packaging material and 90 meters of cloth. A pant requires zero point 0.8 meters of cloth, and a shirt requires zero point 0.9 meters of cloth. So the quantity in the cloth you see 0.8, 0.9. Okay, zero point 0.8 and 0.9. We have already witnessed um, uh, in the question that the maximum cloth is 90. So it is the inequality constraint is less than and equals to. So this constraint is ready. Next is, it takes the tailor approximately 1.2 hours to stitch a pant and zero point 0.9 hours to stitch a shirt. The stitching time of labor you see 1.2 hours for stitching a pant and zero point 0.9 hours for stitching a shirt. So for the pant and shirt, you see pants and shirt, he had a total time for them is 1.2x plus 0.9y. Since we have already been given that the total time he has before the UAE National Day is 120 hours. We have already learned before. So these are the two constraints. We are done with that, and this is the revenue equation 100x. This is for the pants 100. He he get the price of 100, and it for the pants, and 80 dirham for the shirt. So this is the okay. Let's move ahead. After stitching the pants and shirts are packaged separately using special packaging material. Pant needs 1.2 units of packaging material, whereas the shirt needs zero point 0.5 units of packaging material. You see packaging material total was already given. I discussed it before. That was the maximum 80 units he had. Okay, so maximum 80 units material he had. So 1.2 units of material he would be requiring for the pants, and the for shirt he would be requiring the zero point 0.5 units of packaging material. So this is another constraint of packaging material. So cloth, labor, and packaging material. The last is the non-negative constraint. We already know that there must not be any lesser than uh, zero shirt can be produced. So it must be there. So without this, the linear equation cannot be solved. He has enough demand for both. The tailor wants to determine the number of. So the lastly, you see the tailor wants to determine the number of pants and shirts he needs to produce in order to maximize revenue. So we need to know the number of pants and the shirts. When we get to know, we will definitely get to know the maximum profit we may make. It is given that assume that fractional values of shirts and pants are acceptable. So no problem. You don't have to approximate them. Whatever the value, you may use it. Thank you very much. You may use you may find out the value of x and y through the graphical method or through the simplex method or any other method, the linear programming method, and get to know the value of x and y, and you will get to know the profit maximization function, maximum profit you can make. Thank you very much.